Tahniah! Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia, sebuah inisiatif e-Didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda, siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello there everyone. Assalamualaikum and good morning. Welcome to Pusat Tuition Academy YouTuber, a joint venture with e-Didik Malaysia and Kelab Guru Malaysia. #Bermula percuma, selamanya percuma. Before we proceed, let's begin our season with the recitation of Kitab Al-Fatihah. And for the non-Muslim, please recite your prayer according to your religion. Amin, 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 ya Rabbal Alamin. How is everyone doing today? My prayer that everyone is doing fine and ready to proceed with today's class. Okay, let me introduce myself. I am Teacher Su from SMK Seri Sedang Selangor and now live at my channel Umi Su. Before we start our lesson, please subscribe to my channel. As usual, the lesson will last approximately for 1 hour and please follow the class up until the end and give us your full cooperation in making this season a lively one. Please take note that the certificate link will be given at the end of this season. Besides this, don't forget to claim your credit for today's live class. Collect the credit to redeem the attractive prize in store. The link to claim the credit and the presenter username. So my presenter username, Elias Mawa _merah 4 will also be given at the end of the season. However, please be alert as the 1-letter and 4-digit code to claim your credit will be announced 1 digit at a time during the live class. So get ready with your pen and paper. I would also like to remind students to use appropriate language and also use appropriate profile picture. If possible, use your own picture. If you wish to post comment in the chat box. I'm pretty sure all of students here are excellent students who will uphold a positive classroom environment. Okay, students, stay focused, and if you have any question, please write in the chat box and I will try to provide you with the answer. Okay, before go further, let me announce the first code. Okay, get ready with your pen and paper. So let me announce the first code, A2. You can see A2. Okay, the letter is A and the digit is 2. Okay. Are you ready, class? Let's we proceed to our lesson today. Okay, before we go further, let me introduce. My name is Suryati binti Muhammad, teacher at SMK Seri Sedang, Seri Kembangan, Selangor. Okay. Okay, this is collaboration group from Academy YouTuber, Ayu. Okay, this is our collaboration group, Physics Pre-Use STPM Matriculation, lead by Madam Rosmaya. And then this Mathematics Video Collection collaboration, lead by Teacher E. And then this Biology, lead by Cikgu Faiza. And then this Chemistry Pairu, lead by Cikgu Shahnun. And then this is Perekonomian and Ekonomi Prayu, lead by Madam Fizi. Okay, so we proceed to our lesson today. Okay, so now Chapter 1.4, Uncertainties in Measurement. Okay, before we proceed, all of you should know learning outcome from this subtopic. So first, you must calculate the uncertainty in a derived quantity. And then B, write a derived quantity to an appropriate number of significant figure. Okay, so now let's proceed to our lesson. Okay, uncertainty in measurement. So now physics, you should know meaning for uncertainty in measurement. Okay, so what's mean for uncertainty in measurement? You can write your answer in the chat box. Okay, what's mean for uncertainty in measurement? Okay, so the interval in which the true value lies is called the uncertainty in the measurement. Okay, so absolute uncertainty or plus minus value. The absolute uncertainty in the mean value of measurement is half the range of the measurement. Okay, so what is the absolute uncertainty of ruler, class? Okay, what is the absolute uncertainty of ruler? Any answer? Okay, the ruler is increment in of centimeters. The smallest scale division is a tenth of centimeter or 1 millimeter. Therefore, the uncertainty delta X equal to smallest increment over 2 equal 1 millimeter over 2 equal 0.5 millimeter or equal 0.05 centimeter. Okay, why do we measure uncertainty? Why do we measure uncertainty? Okay, why? Okay, measurement uncertainty is critical to risk assessment and decision making. Organization make decision every day based on report containing quantitative measurement data. If measurement results are not accurate, the decision risk increase. Selecting the wrong suppliers could result in poor product quality. Okay, so example, let's say. So this to find uncertainty in different situation. Okay, first, the uncertainty in reading plus minus half the smallest division. The uncertainty in measurement at least plus minus one smallest division. And then third, the uncertainty in repeated data. That means half the range. Example here, plus minus 1 over 2, largest value minus smallest value. And then the last one, the uncertainty in digital reading, plus minus the last significant digit. Okay? Okay, so example here. Suppose the measurement of the diameter of a pin by a vernier calipers are as follows. Find the mean value. So this you want to find the mean value. Okay, class. Please try to solve given example here. You can write your answer in the chat box, please. I give you time to solve this question. Anyone get answer? The mean, the range, absolute uncertainty, and then the last one, you should find the mean value. Class, please write your answer in the chat box. Okay. Tan Clement, 0.25 millimeter. Kahau, 0.25. Another answer? So 0.25 millimeter, this is for what? Tan Clement, how? You find the mean value or the mean, the range. So your answer 0.25 millimeter is for what? Please write your answer in the chat box. Okay, good. Kahau already respond. This for mean. Okay, good. Okay, Tan Clement. Tan Clement, this for mean value. Okay. Kahau and Kahau mean. Okay, now let's we look a solution for this question. So this given here. Okay, so this for data here. So first you should find the mean. So kahau 0.25 millimeter the mean. So the mean that mean you find the data and then you divide with n. So here 1, 2, 3, 4, 5. So you can get 0.25 plus 0.24 plus 0.26 plus 0.23 plus 0.27. You divide by 5 and then you can get 1.25 over 5. So you get answer 0.25 millimeter. Okay. How about the range, class? The range. You already get the mean, so you should find the range. What formula to find the range? Formula to find the range. Very simple. The range equal to what here? The largest value minus smallest value. So what answer for the range? What answer for the range? All of you get answer? Anyone can answer for the range now? Zero. Okay. Who's that? Then Tan Clement, 0.04 millimeter. Good. So the range for this question, 0.04 millimeter. Okay, good. Zhang Holing, Yiling already get answer. Okay, so the range 0.27 minus 0.23, so you get 0.04 millimeter. So now you can find absolute uncertainty. So formula to find absolute uncertainty, we already learned this. So what answer for absolute uncertainty, class? Absolute uncertainty. Okay, the range have to end. So what answer for this? Absolute uncertainty. Anyone can answer? Absolute uncertainty? Come on, class. How to find? Okay, so I show and teacher show how to find it. Absolute uncertainty, that means plus minus the range divided by 2. So you can get here plus minus 0.002 millimeter. So now you want to find the mean value. So the mean value equal to what here? Mean plus minus range over 2. So you can get answer here. What answer for this? Teacher already give formula, so you just find answer. What answer for this question, class? Anyone get answer? Mean value? Please write the answer in the chat box. Come on, class. All of you get answer or not? Already given formula. You just write answer. already given a mean, already given range. So you just write answer. Okay, Tan Clement, 0.25 millimeter plus minus 0.02. Good. Okay, anyone? So this is answer for this question, eh? Okay, so 0.25. 0.23 or 0.27 unyielding. Okay, unyielding. So look at this. Okay, so now mean plus minus range divided by 2. So mean you already get 0.25. So range divided by 2. So this 0.04 divided by 2. So you can get. So this is for your last answer. The mean value 0.25 plus minus 0.02 millimeter. So now unyielding. Understand? Any question? No, So we proceed the next slide. Okay, the uncertainty of the instrument. So this just for your revision. So we already learned the magnitude of plus minus delta X is called the absolute uncertainty. Okay, so absolute uncertainty is the smallest scale of the instrument or half of the smallest scale. It can be determined easily. Okay, this is for example lah. So just for your revision. So given instrument, millimeter ruler, vernier caliper, micrometer screw gauge, stopwatch analog, stopwatch digital, thermometer, ammeter, voltmeter. So this smaller scale division. And then this is uncertainty. Uncertainty equal to what here? Smaller scale division divided by 2. And then this is example of reading lah. Okay, so plus minus 0.05, 0.1 divided by 2, you can get plus minus 0.05, 0.01, you can get plus minus 0.05, and so on lah. Okay, so any question until this? No. Okay, so no question So the smaller absolute uncertainty of the instrument is contribute to the high accuracy, precision, and sensitivity of the measurement system of the experiment. Okay, so look at here, stopwatch here, stopwatch analog, stopwatch digital. Smaller scale division, you get 0.1. Okay, uncertainty or error, you can get plus minus 0.1 also, not divide by 2. Why here, class? Why? Why? Anyone can give reason? Why? Why? So teacher already teach you previous slide. Okay, so the uncertainty in digit reading, so that means plus minus the like significant figure. And okay, so next. Okay, so this is just for your revision. So take reading. So how take the pile of coin here? What answer for this question? Please write answer in the chat box. What answer for this? How thick the pile of coin? Come on, class. The reading for the pile, what answer you get here? This is just for your revision only. Very simple question. Please write your answer in the chat box. What the reading? So the reading 2.30 centimeter. Okay, 2.3 centimeter. Good. Okay, Chan Jung Ki, good. 2.3 centimeter plus minus 0.05 centimeter. Okay, Ning Hao Kok, 2.3 centimeter, good. Okay, so how about value of uncertainty here? So Chan Jung Ki also given an answer here, value of uncertainty plus minus 0.05 centimeter. Okay. Okay, before we proceed to next slide, so teacher will announce the second digit to claim code and price. And so second digit. Okay, get ready with your pen and paper. Okay, second digit. Okay, 8. All you see? 8. Digit of 8. Okay. So we proceed to next slide. Okay, error for the instrument use. Error, so that means uncertainty. So error for the instrument use here. So example here. Okay, measuring the length of the wood block using a meter ruler. So reading. What the reading for this diagram? You can write your answer in the chat box, and then please write the absolute error, so that means uncertainty for the ruler. Okay, please write your answer, class. Two-way communication. Okay, first, absolute error. So uncertainty for ruler. What absolute error and uncertainty for ruler? Please recall. We already learned the previous lesson. Please write your answer in the chat box. Yili, Chan Yuki, Kahau, Wan, Zakirin, what your answer? Please write your answer in the chat box. Please, class. Okay, very simple, class. Okay, so the length is, so you look at here, 10.5. So how about absolute error? So uncertainty for ruler, 0.1 centimeter. So this is for your answer. Okay. So next. Okay, how to calculate absolute, fractional, and percentage uncertainty. So let's say this is a diagram. So this diagram, smaller scale division. What smaller scale division here? So smaller scale division equal to what here? Smaller scale division equal to what? Okay, equal to 0.2 milliampere. So this one. So this is for smaller scale division. Okay, so reading for this. So reading. So this arrow kan. So reading. Reading equal to what? 1.6 milliampere. So this one 0, 5, 6, 7, 8 and so you can get 1.6 milliampere lah. Okay. So for this first, you should find or you should calculate absolute uncertainty. So this formula to calculate absolute uncertainty. So delta I. So half 0.2 milliampere. So you can get answer 0.1 milliampere. Okay. And then your reading here 1.6 plus minus 0.1 milliampere. Okay. So this for absolute uncertainty or error. And then now find fractional. So fractional uncertainty. So what formula to find fractional uncertainty here? So fractional uncertainty equal to uncertainty over value. So uncertainty here equal to what here? 0.1. And then value 1.6. Value that's me reading here. Okay. So you can get 0.1 divide 1.6. You can get equal to 1 over 16. Okay. And then your reading I equal to 1.6 plus minus 1 over 60 milliampere. So now we go to percentage uncertainty. So percentage, so that means percent. You should time with 100. Okay. Percentage uncertainty equal to what here? Uncertainty value times with 100. Okay, so you can get 0.1 here. Okay, divide 1.6 reading times with 100. Okay, you can get 6.2%. So your reading now, I equal to 1.6 plus minus 6.2% milliampere. Okay, so we proceed to next slide. So until this, any question? Any question, class? Okay, so we proceed to next slide. Analyzing uncertainty. Okay, so analyze. You should analyze. So that means first you should find. Okay, in this subtopic, we'll deal with the repetition reading of data here. So repetition measurement to produce more accurate data. Okay. It's not that if we have more than one reading, so the true value is the mean of the reading. Okay, so this formula, mean value for A is, okay, means mean, and you already learned in mathematics at math, means sum of S over N, sum of data over N. Okay, so this mean. So this is for symbol for mean. Equal to A1 plus A2 plus and so on plus AN over N. So this data and then this value for data. Okay. So this mean value for A. A1 plus A2 plus AN over N. So 1. Delta A should be calculated this way. Okay. S1. S1 means this is a value for data minus A. What's mean for here? This is for mean. Okay. And then you find S2 and so on. And then Sn, An minus mean. Okay. So second, you find the sum of duration. Okay, so formula here S equal to sum of N1 Sn. What formula given here? S1 plus S2 plus and so on plus Sn. Okay, so 3, find the mean of division. So mean here, so this formula for mean equal to S over N. Okay, let's say estimate random uncertainty associated with the average here. So example here. So diameter D of a wire was measured several times to reduce the uncertainty, and the reading is given in the table below. Find the value. So true value, that's mean value, and the uncertainty of the diameter. So you should recall formula to find mean value and then formula to find uncertainty. Okay, so this is table given. So you should find what here? Key point for this question. Find the true value and the uncertainty of the diameter. So please try to solve this. So please find the mean value and the uncertainty and then write your answer in the chat box here. Okay, class, please write your answer. What formula for mean value? What formula the uncertainty? Anyone can answer? The true value or mean value. What answer for true value or mean value? So mean equal to what? Sum of X over N. Okay, so what answer for this? Anyone can answer? Please write your answer in the chat box. Anyone can answer, please, class? Tan Clement, 1.535 centimeter plus minus 0.05 centimeter. So this for what here? Mean value or uncertainty? 1.435 centimeter plus minus 0.015 centimeter. Anyone? Anyone get different answer with Tan Clement? Please write your answer in the chat box, please. Okay, so first, to solve the question, you should find or calculate right here. Calculate the true value or diameter. So that means mean value. So this is given formula. Diameter denote with D. So this is for data here lah. Okay, so D equal to, so data. So you can get 1.55 plus 1.52 plus 1.54 plus 1.53 plus 1.54 plus 1.53 divide by 1, 2, 3, 4, 5, 6. 6. So you can get here, so 1.54 centimeter. Okay, please end. So you look at here, given data. Given data 3 SGF. So your answer must follow the given data. So 3 SGF here. Okay. So now you must calculate the uncertainty of diameter here. So what formula to calculate uncertainty of diameter? So given in table are very easy to calculate here. So here, this is data 1.55, 1.52. So this data from answer, and then deviation. So deviation, what formula to find deviation here? So deviation D. D, what's mean for D here? Okay, D is for what? So here, data minus this is for mean or true value. So you can get magnitude 1.55 minus 1.54. So you can get 0.01. So and so on, 0.02, 0, 1.53 minus 1.54, you can get negative 0.01. Okay, so here you can get 0. So for this, you can get 0.01. Okay, so magnitude, so your answer is positive. So sum of D equal to what here? 0.01 plus 0.02 plus 0 plus negative 0.01 plus 0 plus negative 0.01. You divide by 6. And then your last answer, you can get plus minus 0.01 centimeter. So this for what? 0.01 centimeter. So this is estimate uncertainty here. So that means you can get D equal to 1.54 plus minus 0.01 centimeter already given here. Okay, so the diameter of the wire should be written 1.54 plus minus 0.01 centimeter. Okay. So we go to next slide. Okay, error for the instrument used here. So measuring the length of a wood block using a meter ruler. So you look at here. Okay, so this given question, the length is 10.5 plus minus 0.1 centimeter. So now the previous lesson we find the length. Okay, now for this you should find fractional error. So this is for absolute errors or uncertainty. So you find fractional error. So what formula to find fractional error, class? Fractional error. Okay, please find fractional error. Fractional error. Okay. So fractional error equal to absolute error. So you divide with here reading 10.5. So that means you can get here 0.00952. Okay. And then you find percentage error here. Percentage error equal to what here? 0.1 divide by 0.5 times 100. So you can get 0.952%. Okay. So this micrometer screw gauge. So you look at here, already given uncertainty or error here, absolute error. This is 0.01 millimeter. This is for uncertainty. Okay. Error from the instrument used. So that's mean for micrometer screw gauge here. Example, measuring the length using a micrometer screw gauge here. Okay, so what value for this? Okay, so value for this. We already learned from 445, right? How to take a reading for micrometer screw gauge. Okay. So what the reading for this? Class, can you write answer in the chat box? What the reading for micrometer screw gauge? And then you already know the error or uncertainty for micrometer screw gauge plus minus 0.01 millimeter. So you just write reading for this micrometer screw gauge here. So this reading. Okay, class, all of you get or not? Okay, very simple. The length is equal to what here? So 5.5. Okay, so this 0.30. So 5.5 you plus 0.30, you can get 5.80. So 5.80, so plus minus 0.01 millimeter. So this for absolute error. Okay, so from this you can find fractional error, you can find percentage error. So very simple. So fractional error 0.01 over 580. So you can get 0.00172. And then for percentage error equal to what here? 0.01. Okay, over 580 times 100. Okay, Clement get what here? 580 millimeter. Okay. Thank you. Okay, this Chan Jung Ki, 580 millimeter plus minus 0.01 millimeter. So this is reading for micrometer screw gauge. Thank you, Chan Jung Ki. Thank you, Lim Kek Wei. Good try. Okay. Okay, so now this is for percentage error. You can get 0.172%. Okay. So we proceed to next lesson. Determination of uncertainty here. So for this addition, subtract, multiply, divide. So you should know formula to find. So determination and uncertainty, first addition. So addition given if x equal to p plus q. So then if delta x equal to delta p plus delta q. So example here. So example, okay, if given reading 1, 3.60 plus minus 0.02 ampere. So that's mean given reading 2, 6.40 plus minus 0.02 ampere. So then your reading. So that's me reading I 3.60 plus 3.40. So this one you added and then you plus here plus minus 0.02 plus 0.02. So your last reading here, I, so 10.00 plus minus 0.04 A. Okay, so let's exercise. Okay, so the length of a copper wire at 30 degree is 18.2 millimeter plus minus 0.04 centimeter, and at 60 degree 19.7 millimeter plus minus 0.02 centimeter. Find the absolute uncertainty and the attention of the wire. Key point for this question. Find the absolute uncertainty and the attention of the wire. So you must find two things, right? So please find the absolute uncertainty, class. Write answer in the chat box. What absolute uncertainty here? Anyone can answer? Kahao, Chan Yuki, Zhang Hong, Clement, please write your answer in the chat box. You get answer or not? Okay, so find the absolute uncertainty. Solution here. Absolute uncertainty equal to what here? So look at here. Already given 0.04. You plus, so second 0.02. So you can get 0.04 plus 0.02. So that means you can get 0.06 centimeter. So how about attention of the wire? Attention of the wire, so equal to, you convert millimeter to centimeter because given here absolute error or uncertainty in centimeter unit. So that means you can get here 1.97 minus 1.82. So plus minus already get absolute uncertainty, plus minus 0.06. So your last answer equal to what here? 0.15 plus minus 0.06 centimeter. So until this, any question before we proceed to how to determine of uncertainty addition? Okay, so now first we finish subtract, so second addition. First we finish addition and then for second subtract. So any question before we proceed to subtraction? So any question? Okay, no. So we proceed to next. Determination of uncertainty for subtract. Okay, subtraction. Okay, this is given formula. If x equal to p minus q, then if delta x equal to delta p plus delta q. Okay, so here. Example here. Okay, temperature increase equal to final temperature minus initial temperature. So theta here equal to theta 2 minus theta 1. Okay, let's say example given theta 1, 25.2 plus minus 0.1 degree, and then theta 2, 65.4 plus minus 0.2 degree. So that means you find temperature increase, final temperature, so that means theta 2 minus theta 1 lah. Okay, so you can get 65.4 minus 25.2 plus minus. So this for what here? This for absolute error, uncertainty. 0.2 plus 0.1 degree. So your answer you can get 40.2 plus minus 0.3, 60 degree. Okay? Easy, eh? Okay, exercise. The mass of the water bottle of an average worker before and after a walk is 300 gram and 127 gram respectively. If the absolute error is 0.5 gram, find the loss of mass of water correct to the appropriate degree of accuracy. Okay, class. So key point for this question, key point here, find the loss of mass of water and then correct to approximate degree of accuracy. So class, can you find loss of mass of water? Please write your answer in the chat box, please. So far you find mass before the walk first, mass before the walk and then mass after the walk here. So first, please write your answer, mass before the walk here. What answer, mass before the walk here. Please write your answer in the chat box. Kahau. So this kahau, 173 plus minus 0.5 gram, 173. Okay, so kahau, this is for your last answer. What here? So this is Tan Clement, 173 plus minus 0.5 gram. Okay, good try, good. Okay. So this is for last answer for this question. And so first you find solution here, mass before work here, 300 plus minus 0.5 gram. And then mass after work here, 127 plus minus 0.5 gram. And then mass of the water used up. So you can get answer 300 minus 127. So plus minus 0.5. So your last answer 173 plus minus 1 gram. Okay, good, Tan Clement and Hot Cow. So good, you'll get the correct answer. Okay, so let me proceed to next. Determination of uncertainty, multiplication, multiply. So multiply. So example here. So for this multiplication, you already learned in AdMath. So multiply indices and logarithm. So let's say here. Okay. if x equal to ab square, so that means you log right hand side and left hand side. So that means log x equal to log ab square. So that means, so for this you simplify. So you can get log x log a plus log b square. So this b, so up there you bring to front here. So you can get log x log a plus log 2 logarithm b, 2b logarithm x. So now for this you can get here lah. So differentiating the equation, you can get here, differentiate, you can get here. Delta x over x here. So for this end, so equal to delta a over a plus 2 delta b over b. And then in terms of uncertainties, you can get here, delta x over x. So that means you added here plus minus uncertainty. So 2 here plus minus. And then you can get delta x equal to what here? You bring x here. So this is this formula for multiplication. Okay, so now, before we go to exercise, like we take a break first. Okay, we take a break. Okay, we shall take a break for the advertisement. Okay, stay.
Wow, banyaknya hadiah menarik menanti anda.
Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma.
Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang.
Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.
Okay, thank you guys. So now, are you still with me? Okay, so let's we proceed to exercise. Okay, so this is multiplication. So this is for example here. Okay. So multiplication example given, area of rectangle equal to length times width. So this formula, area equal to LW. Okay, so if given L 50 plus minus 0.1 centimeter, and then given W here 25.0 plus minus 0.1. So for this, you can find here. Then A, so you times lah. 50, you times 25, you get 1250 centimeter square. Okay, so that means you can get, this is formula, delta A per A plus minus delta I per I plus minus delta W per W from this end, from here, area of rectangle here. Okay, so that means you just substitute value lah. A, 1250. So here, so you just substitute value, delta A here. So you can get the answer lah. Okay, plus minus 7.5. Okay, so that means plus minus 8 centimeter square. So the record value of area 1250 plus minus 8 centimeter square. So this is for your exercise here. Okay, so this is for your exercise. The weight of an iron block is 8.0 plus minus 0.3 Newton, and it's based on a wooden base of area 3.5 plus minus 0.2 meter square. So find the percentage uncertainty of the value and then calculate the pressure exerted by the block. So key point for this question, you should find what here? Find the percentage uncertainty, and then you must answer and then you must calculate the pressure exerted by the block here. Okay, so please try to solve first. Because all of you get answer or not? Percentage uncertainty in the weight here. What answer for percentage uncertainty in the weight here? Okay. What answer for percentage uncertainty in the weight here? 1, Zakiri, Suyao, and Yili. You get answer or not? Please write answer in the chat box here. Please try. Okay, for solution and solution first, you should find percentage uncertainty in the weight here. So that means 0.3 divided by 8, you times 100. So you can get 3.75 Newton. And then you find percentage uncertainty in the area equal to 0.2 over 3.5 times 100. So you can get 5.71. And then percentage uncertainty, so 3.75 plus 5.71. So you can get here 9.46. And then pressure. So pressure, what formula for pressure here? Force over area, right? Pressure equal to F over A. So that we can get 8 over 3.5. So you can get 2.3 Pascal here. So absolute uncertainty in the pressure, you can get 9.46 divided by 100 times 2.3. So you can get 0.22. So your answer here, since both the weight and the area have been approximated to 2 SGF, significant figures, the final answer must take the same formula. Okay, so that means your last answer, pressure equal to 2.3 plus minus 0.22 Pascal here. Okay, so now last. This is for division here. Okay. So any question until this? Okay, determination of uncertainty for division here. So divide. So if y equal to c over d. So this is logarithm formula you already learned in MAT. Okay, so both sides you put log here. So that means log y equal to log c minus log d. Okay, so differentiate here the equation, you can get delta y per y equal to delta c per c minus delta d per d to maximize the estimated uncertainty. So that means you can get delta y over y plus minus delta c over c plus minus delta d over d. So you can get delta y, you bring here y here, so you can get this lah. Okay, so this for example division. Okay, density equal to mass over volume. So density m over v. So this formula given. Okay, if m 80.0 plus minus 0.2 gram and then given v volume 40.0 plus minus 0.2 centimeter to the power of negative 3. So that means then you should find P lah. P 80.0 divided by 40.0, so you can get 2.00 gram centimeter to the power of negative 3. And then you find absolute, so that means delta P over P, given formula and already given formula. So this you just substitute value lah. You just substitute value here. Delta P over 2 plus minus 0.2 over 80 plus minus 0.2 over 40. So the uncertainty, delta P you can get here plus minus 0.05. And then you can get delta P divided by 2 and you can get plus minus 0.02. So your last answer, value of density here, delta P 2.0, where you get 0.2. This is 2.0. Okay, plus minus absolute uncertainty here. So this is for your last answer lah. Okay. Okay, this is for example on error analysis lah. So example of error analysis here. Okay, the following reading were obtained by student to determine the density of metal of a cylinder here. So this is given question lah. Okay. Calculate the density of the metal to the correct number of significant figure. Key point here, you must calculate the density of the metal to the correct number of SGF. So, can you try? So, you find density first. What formula for density? Very simple. Density equal to mass over volume here. Anyone get answer for this? Okay, so now for this end, solution here. So this is length of cylinder. So this for length of cylinder denote with L, diameter of cylinder denote with D, mass of cylinder denote with M. So density equal to M over V, mass over volume. So you can get, this is formula for volume lah, pi r square over L, pi r square times L. So this is, you can get lah, R radius, so diameter D over 2 square lah. So you can get here. Okay. So 513. So you can get mass of cylinder here. Okay. So pi here, this is for what here? R. Okay. This diameter. Okay. You millimeter, so you change lah. Okay. So this is for substitute all the data, and then you can get this. This is for raw calculation here. Okay. So next step. So this is for delta L, delta D, delta M. Okay, so delta P equal to error in the density here. So you can get therefore delta P over P, delta M over M plus 2 delta D over D plus delta L over L. Okay, so this is your question. So delta P 10.080. So this 1 data 1. Okay, so here delta M over absolute plus 2, 0.1. So this for what here? Delta D. So this is for L. Okay, so you can get here. This is for answer. And then you can get 0.2 gram centimeter to the power of negative 3. Write in one significant figure. Okay. And then your last answer. Density of the meter, you can get 10.1 plus minus 0.2 gram centimeter to the power of negative 3. Note that the density is written down to the first decimal place because error occurs in the first decimal place. So until this, any question, class? So until this, any question? Okay, so now let me check your understanding for our subtopic today. Okay, so please try to solve given quiz, very simple quiz here. Okay, teacher will paste the link in the chat box, and then please try and okay, the link for the quiz already pasted in the chat box. Please click and then write your name. Okay, please click and then write your name. Okay, try to solve given question. Okay, class. Okay. So this is the third digit code. So third digit code is 8. Okay. Please take note and write your digit code to claim your credit. Okay, so please try it. Okay, so this for third code. Sorry, and this is for third code 4. Okay, 4. Please write it. Okay, class, please try solve given quiz here. Class, please. Player. Okay, class, please. Please click the quiz. The quiz link already given. Very simple quiz here. Anyone please submit answer? Okay lah, so let's continue our lesson to next class. So, okay, thank you class for joining physics tuition class today. Okay, please end. So the last code will be announcements after this. Okay, we've got Grace. Okay, so now we have reached the end of today's season. Congratulations to those who are able to follow my live class from the beginning until the end. Again, students, please click in the subscribe button and activate the icon bell so that you will not miss the next live class, and also don't forget to hit the like button here. Okay, now let me announce the last code here. Okay, let me announce the last code. The last code, now this digit 3. Okay, 3. Okay, now all of you already get 4-digit code, so I will put the certificate link and the link to claim the credit here. So certificate link. Okay. Paste. So this for certificate link. So this for credit. Okay. So the certificate link and the link to claim the credit are already in the chat box. Please click and okay, the certificate and credit link are given as a token of thanks you for your dedication in joining the free online class today. And please share to the live class to your friend on your social media. Spread and share the goodness. Okay, please take note. The credit link will end 50 minutes while the certificate link will end half an hour after the live. Make sure to use the EDD email only to log in. Incorrect email use will not be entertained. Okay, so already given or email EDDN, so teacher given, so teacher paste. So email, EDD email already in your chat. Okay, if you wish to get more information on the online class, go to www.academyyoutuber.com. And to those who haven't joined EDD Junior Telegram, please do so. Okay. So once again, I would like to thank all of the wonderful students for joining today. Thank you for being an IU supporter. You are awesome. Okay, you are awesome. Feel free to share this free tuition class to your friends and teachers all over Malaysia. This is collective effort from all the teachers throughout Malaysia for all the students throughout the country. Till we meet again, ingat hashtag bermula percuma, selamanya percuma. Okay, stay safe and be safe student. Assalamualaikum and bye-bye. So we continue our lesson next class. Okay, bye-bye. Thank you joining our class.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata ganjaran kredit IU untuk dikumpul. Jom ikuti kelas tuition live IU untuk mengumpul kredit IU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. layari www.academyyoutuber.com untuk maklumat lanjut.